Okay, so I'm picking up exactly where I left off in the previous video. Now that we went a little bit slow and I introduced you to some of the technical stuff of Mental Ray, like the render settings, the render view, how to test render, we can actually move a little bit faster here. I'm not going to be moving too fast for you. This is an introduction to Mental Ray, and I do assume that you have no experience or very little experience rendering at all, let alone rendering with Mental Ray. So what we're going to do now is we're going to go over some direct lighting with Maya, and we're going to check out some of the lighting here and just go over that very quickly because lights in Maya are very important to Mental Ray. Okay, so let me close this. Let me take this cone here and I'm just going to move it here, kind of rotate it around. Doesn't have to be perfect, whatever, it doesn't really matter. Okay, now if we do a render, there's our default lighting and we went over that, and we can turn that default lighting off. Now there's a couple of ways that we can turn off the default lighting. We can manually go in the render settings, go to the common tab and scroll down here and uncheck the enable default light parameter right there. Let's close that. Or we can create a light in Maya. When you create a brand new light in Maya, Maya basically thinks to itself, oh, okay, they created a light, so let me turn off the default light. So basically when you create a light in Maya, the default light is turned off automatically, so you don't have to worry about that, about turning it on or off. Okay, so let's go ahead and start creating our first lights here inside of Maya. If I go over to the create menu, I go to lights, I get all these different options for lights. I could tear this menu off by clicking once here on these lines up here at the top of the window. Okay, and then I can drag this little window anywhere I want. So I'm going to keep it open here, that way I can just create my lights very quickly. So we have here an ambient light, directional light, point light, spotlight, area light, and a volume light. So let's very quickly go over all of these lights here. We have an ambient light. Let's go ahead and click on that to create an ambient light, and we can't see it because it's inside of that cylinder right there. So what I'm going to do is simply move it up like so, and there's our little ambient light. And if I do a render here, we can see there's the ambient light. Okay, what I'm going to do is I'm going to go ahead and click on IPR to do an IPR, and I'm going to do a region over this area right here so I can make changes very quickly and on the fly. Next thing I'll do, with the ambient light still selected, I'll hit Control and A to open up the attribute editor here on the right, and I can go ahead and change some of these parameters. Now I don't like to use the attribute editor like this simply because it resizes my viewport and it kind of slows down the visual feedback here of Maya. I just don't like that little hiccup right there. You see that? Every time you open and close the attribute editor. So what I'm going to do is I'm going to come down here. I'm going to click on this little icon here that has a little picture of a sort of running man down here in red, kind of like a little red wireframe. And I'll open up the settings and preferences window here. Let me hit cancel. Another way to open that is simply to go up here to the window main menu, go to settings and preferences, and then just click on preferences. Same exact thing. Okay. What I'm going to do is I'm going to tell Maya to open the attribute editor in a separate window right here. It's the first item under interface. And down here you'll see open attribute editor. Just click on separate window, hit save. And now when we open up the attribute editor, it'll open up in its own independent window, which is exactly what I want. That way I can resize it, I can move it around, I can go ahead and hide it whenever I want, bring it back. It's just a little bit more flexible. Okay, so I'm kind of sidetracking there from Mental Ray, going more to Maya options here. So let's keep moving. Okay, so some of the important parameters here in settings in the attribute editor is things like the color. We can adjust and change the color here. So if I hit color, a color chooser window opens up and I can choose different colors. So I can change the color of this light to anything I want. Let me change it back to white, hit accept. And I can also change the intensity of the light. So you can see here I can lower the intensity of the light, or I can increase it, so on and so forth. Pretty easy to use. I can also change the ambient shade, and this parameter is a parameter specifically for the ambient light. Okay, so you can see how that works. Pretty interesting. Let me set that back to 1 default. Down here we have a shadows tab, so let's go ahead and click on that. And that's going to go ahead and open up the shadow color, so I can actually change the shadow color. You notice that even though the IPR is updating, there's no change. That's because right now this light is not set up to use shadows. I have to first turn on this checkbox here that says use Raytrace Shadows. And now you can see that we have shadows in our scene. Okay? And now I can actually change the shadow color. You can come in here and say make it green. And you notice that the shadows come out green. I'll hit cancel to undo that. Put the colors back to black. Okay, so we can change the shadow color. We also have the shadow radius parameter that allows us to soften up our shadows. We have to increase the shadow rays here. And you notice that our shadows are not they're not softening up, and they look pretty bad. The reason that is because of the ambient light. We'll get to see that later once we use a different type of light. Okay, the ambient light doesn't exactly soften up the shadows, and the shadows work a little bit different with the ambient light. Okay, and then we have a few other things down here for, say, first shading, which we're not going to get into, and a few other things like object display, which is just going to go ahead and affect the object itself and not the lighting of it. Okay, so it's not important to what we're doing. Okay, so with that done, let's go ahead and close that. And let's close this render view window there. Let's take that ambient light and let's delete it. Let's create a directional light now. And again, it's inside of our cylinder there. And if we scale this light up, you'll see that the icon is a series of arrows pointing in a specific direction depending on where you actually orient these arrows to. And a directional light shoots parallel light rays. What that means is that there's no defined point of origin from these light rays. Basically, in layman's terms, it mimics the sun. So use this if you're doing some kind of sunlight lighting in your scene. So if I go ahead and do a render, you'll see that the lighting is coming from above. And if I go ahead and rotate this into another direction, let me do an IPR so we can get some instant feedback here. As I rotate the light, you notice that the light changes right there in the IPR. In the IPR, okay? So let me go ahead and open up the attribute editor for this light, and again, we can change the color and the intensity. If we go down to shadows, we can turn on shadows. Now we can use depth map shadows, or we can use Raytrace Shadows. What's the difference between these two? Well, depth map shadows are not physically accurate, but they're faster to render. The downside is they're not physically accurate. The upside, or the positive side to this, is that they render much faster than Raytrace Shadows, even though they're not physically accurate. So it's a trade-off. Raytrace Shadows, on the other hand, are very physically accurate and contain a lot more information than depth map shadows. The problem with Raytrace Shadows is, because they look so much better, they take longer to render. So again, it's a trade-off. So if I turn on use depth map shadows here, you'll notice that now I have shadows in my scene. So let me actually go in here and rotate this directional light around a little bit. You can notice as I rotate it around, the shadow positions change, almost like a sundial. Okay? And that's because this imaginary sun is changing positions in the sky. So just like the sun would change positions in the sky in the real world, which is actually the Earth rotating, of course, but based on the position of the sky in the sun, the shadows will actually change. And that's exactly what's happening here inside of Maya. So let me turn off use depth map shadows, and let me collapse that and switch on use Raytrace Shadows. And if I increase the light radius, you notice that the shadows become blurry. And now they become all grainy. To combat some of that graininess, we have to increase the shadow rays here. But increasing these shadow rays is going to slow down our render time pretty drastically. So you want to not use this light angle too much, or not abuse it, I should say. Even though it looks pretty neat, looks pretty cool. Okay, so let me go back to the default settings. Then we have a mental ray tab down here. And most of the lights inside of Maya have a mental ray tab that allow you to use specific mental ray settings and parameters with these lights. For example, we can make a light become a photon emitter, and we'll talk about that later. We can also turn some of these lights, not all of them, but some of them can be turned into mental ray area lights, and we'll be looking at that in the next video immediately following this one. Okay, so that's pretty much going to do it for all the main parameters for the directional light and the directional light itself. So let me close that, and let me delete this. Now let's create a point light. So what's a point light do? Point light, the icon looks very similar to the ambient light, but there is a key difference. The point light works like a light bulb. A light bulb shoots lights in all directions, all around it, right? That's exactly how the point light works. It's basically shooting light 360 degrees around it. Above it, below it, to the left of it, to the right of it, in front of it, behind it. Any direction, you name it, it's shooting light in that direction. You also notice that we have this decay rate parameter that wasn't available before with the directional light or the ambient light. What is the decay parameter? Well, by default, it's set to not create any decay. Let me show you what that means. Let me turn on shadows here so things just look a little bit more interesting. I'll turn on Raytrace Shadows. I'm going to do an IPR. Okay, there we go. So there's our shadows and our point lights right there working just like a light bulb in a ceiling. Okay, so there's our shadows. Let me collapse the shadows tab there. You notice that we also have a mental rate tab here for the point light. And what I'm going to do is I'm going to turn on decay rate, and we have three options down here: linear, quadratic, and cubic. Okay, what's the difference between all of them? Well, let's choose linear, and you notice that the image goes black. Why does that happen? Well, what does decay rate mean? When light decays, that means it's behaving the way that light behaves in the real world. In the real world, light energy coming from any light source, whether it's the sun, whether it's a flashlight in your hand or a light bulb in the ceiling of your room, light is going to go ahead and decay. That means that the energy is going to go ahead and fall off and decrease as it travels over distance and time. That's the way that light works in the real world. Now, light in the real world works more like this quadratic mode here. Okay, so why is there a linear mode and a cubic mode? That's so that you have the option of using those two different types of mode of decay in case you want to. In case you don't want to go for extreme realism in your scene and you just want to control the decay rate in a different fashion, you can do that in a linear fashion or in a cubic fashion. So let's use linear right here. And again, the image comes out black. That's because by adding decay, this makes the light intensity drop off. And because the default is set to 1, it's too low. So we need to increase that. And as we increase it, you can see that the light is starting to be introduced in the IPR again. So an intensity of 10 gives us this very dim lighting. Let's change the intensity to 100. And now it's pretty bright, so let's change it to, say, 50. So that's a little bit better. So you can see that the light is behaving just like a light would in real life. The closer that an object is to the light, the more brightly lit its surface is going to be. The farther away an object is, the less light it's going to get because the light starts to decay over the distance as it makes its way to that object. And I hope that makes a lot of sense. And it works the same way that lights work in the real world. Okay, so that's the most important thing here. Then we have quadratic. The quadratic method mimics the way that lights work in the real world even more, because lights in the real world fall off using this quadratic formula. Okay, so if I increase this to, say, 100, it takes more light energy for the quadratic formula to actually work and actually allow our light to be visible. So there we go. At 500, this is the way it looks. And this actually mimics the way that a light would behave in real life if it were in the same situation as our little 3D scene right here. And if we switch over to cubic, you'll notice that now we need a lot more light energy to be able to see anything in our scene. That's because the light is decaying based on the cubic formula there. And of course, that's going to go ahead and take a lot more light energy to get some more lighting in that scene. Okay, so that's the point light. Let me go ahead and close that, and I'll select the point light here, delete it. Then we have a spotlight. Spotlight works exactly as the name suggests. Spotlight works like a spotlight, very similar to a flashlight or a spotlight in a play or in theater. Okay, we can scale up the icon here to see it a little bit better. If we open up its attribute editor, again Control A, we get a lot of different parameters. Let me go ahead and do an IPR render here. Okay, there we go. There's the spotlight. As you can see, it just creates a cone of light over a specific area, the same way that a flashlight would. Okay, we can change the cone angle right here simply by changing the cone angle parameter. So it can have a larger cone angle by changing this radius. We can also change the Penumbra Angle here. So you notice that we get this softening of the light at the outer edges as opposed to a harsh light. If I set this back to 0, you notice that now the light is this perfect sort of stencil type circle here which is perfectly lit up or perfectly dark. If we don't want that, which looks pretty fake, we can go ahead and increase this Penumbra Angle, and we can add that softness to the edges there. We can also add drop off here, which is going to soften up the spotlight as well, as you can see here. So now it doesn't look so much like a spotlight, even though it still is behaving like a spotlight in a sense. It also has decay rate, just like with the point light, and we have the same parameters: no decay, linear, quadratic, and cubic. I'll leave it on no decay for the moment. Okay, and down here we have more mental ray parameters. Now this time we have something that we didn't see before, which is the area light. We have an area light parameter. What this does, it creates a mental ray area light. We're not going to go over that right now. We're going to go over that in the next video, where I'm going to talk about that specifically. But that's going to do it for the spotlight. So spotlight, pretty simple to use, very easy. And then down here we have an area light, and the area light is a very interesting type of light. I need to go ahead and rotate that so it's pointing down to my scene. It works very similar to a spotlight in the sense that it has to be pointing or aiming at the direction where you want the light to go to. Let me do an IPR. Okay. Let me go ahead and increase the intensity there. You see that the area light looks very soft and very realistic. It's very interesting, awesome light to use. If you're going for realism in your scenes and very realistic, nice, faithful lighting, you want to use an area light, because the area light is going to give you a very nice result, as you can see. It gives you these nice area light shadows that are very realistic, and very realistic soft lighting, which is fantastic. And down here, of course, we have the mental ray parameters, and we'll look at that in the next video. Okay, so that's the area light. And remember that it has to point and aim at whatever it is that you're trying to light up with it. So let me delete that. And then we have a volume light finally over here. And volume light is this little circle right here, little circle icon. Now the volume light works completely different from the other lights. If I go ahead and open up the attribute editor, do an IPR, you'll notice nothing happens. If I increase the intensity to say 1000, nothing happens. So what's going on? The thing that's happening here is that this type of light is different than the other lights in the sense that only the things that are going to be the objects that are going to be lit up have to be inside the sphere of influence. So I have to scale it up like this. So anything that's inside of this sphere, represented by this icon, will be affected by the light. Anything that's outside will not be affected by the light. This is very unrealistic and is not the type of light behavior that you would see in the real world. So what's this light useful for? Well, this light is useful for if you're just customizing a light rig and setting up some lighting in your scene. Let me do an IPR here. And you have some areas that are perhaps a little bit too dark and you're trying to brighten them up. You can use this volume light to brighten up only the area that you want it to without affecting anything else. Okay, so it's a very useful light in that sense. And we have a color range here which we can change. So we can adjust the lighting here to anything that we want. We can see an update in the IPR. We can add more color swatches to this. And this can be a totally unrealistic light, as you can see. So just by color changing this ramp position here, we can change the color range. We can also change things like the penumbra down here and things like that. We can also go ahead and add some shadows here if we wanted to, which works just like the shadows that we've seen so far. And there you go. That's the volume light. Okay, so let me close that. Alright, so that's going to do it for this video here. I'm going to end it here, and in the next video we're going to talk about mental ray lighting specifically, because right now we've only covered the Maya lights, and there's a key difference between Maya lights and mental ray lights. There are two different types of lights, but we're going to see how we can use Maya lights to create a mental ray area light in the next video.